Hello everybody, my name is Askar Khan, your math coach on Wisdom Outlined Coaching, helping you learn. Welcome to this channel. In this lesson, we will study about operations on real numbers, how to add and subtract rational numbers and irrational numbers, how to multiply and divide rational and irrational numbers. So let's dive deep into the lesson. Let's look at the first principle. The sum or difference of a rational number and an irrational number is always going to be irrational. For example, is 2 a rational number? Yes. Plus, is square root 3 an irrational number? Yes. So when you add the two, the sum is going to be an irrational number. Similarly, the difference of a rational number and an irrational number is going to be irrational. So get the point? The sum or difference of a rational number and an irrational number is always irrational. Let's look at the second fact. The product or quotient of a non-zero rational number with an irrational number is always going to be irrational. So let's take an example. 2 is a rational number multiplied with an irrational number root 3. The product is 2 root 3, which is also irrational. So we learn that the product of a rational number, of course the number should not be 0, multiplied with an irrational number will always be irrational. Similarly, the quotient of a rational number, is 7 a rational number? Divided by an irrational number, the result will also be an irrational number. So, got the second fact clear? The product or quotient of a non-zero rational number with an irrational number is always irrational. Let's look at the third fact. If we add, subtract, multiply or divide two irrationals, the result may be rational or may be irrational. So let's multiply two irrational numbers. For example, root 2 multiplied with root 2 is square root 4, which is 2, a rational number. You see the point now? When two irrational numbers are multiplied, the result could be a rational number or an irrational number. For example, square root 2, an irrational number, multiplied with square root 3, which is also an irrational number. What is the product? It is square root 6, which is again an irrational number. So, the product of two irrational numbers could be rational or it could be irrational. And the same thing goes with division, addition, subtraction. We will learn more about this in the following examples. Let's try to understand this. Don't worry about the example number. Focus on the concept. Add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. So let us write it down like a sum. 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. Now let us put down the root 2's together and then the root 3's together. So our next step is going to look like 2 root 2 plus root 2 plus 5 root 3 minus 3 root 3. And this is simple addition. When there is no number written, it is understood to be 1. So just add them together. 2 plus 1 is how much? 3. So it's going to be 3 root 2. Similarly, 5 minus 3 is how much? 2. So it's plus 2 root 3. So this is the final answer. 3 root 2 plus 2 root 3. So basically what you're doing is you are adding the numbers and keeping the irrational number the same. So let's try another one. Can you try this? 5 root 6 plus 8 root 2 minus 3 root 6 plus 7 root 2. So let's put the root 6 together and then the root 2's together. So how does it look like now? It's going to look like 5 root 6 minus 3 root 6, then plus 8 root 2 plus 7 root 2. Now we simply subtract 5 minus 3, which is going to be 2. So it's 2 root 6. And then 8 plus 7 is how much? So it's going to be 15 root 2. So now do you understand how you add or subtract two irrational numbers, or a rational number and an irrational number? Now let's look at how we multiply. Multiply 6 root 5 by 2 root 5. In other words, 6 root 5 multiplied with 2 root 5. So let's group them together for our convenience. 6 times 2 times root 5 times root 5. Now 6 times 2 is how much? 12 times root 5 times root 5 is square root 25. 5 times 5 is 25. The next step, 12 times root 25. Square root of 25 is 5. Good. Now 12 times 5 is 60. So now do you understand how you multiply two irrational numbers? Let's try another one. Let's try this. Multiply 3 root 2 times 4 root 3. So let's just group them together for our own convenience. 3 times 4 times root 2 times root 3. Now 3 times 4 is 12 times root 2 times root 3 is square root. 2 times 3 is 6, which is 12 root 6 is the answer. Great going. Let's see how we divide. Divide 8 root 15 by 2 root 3. So let's go ahead and try this out. 8 root 15 divided by 2 root 3. Now observe carefully. Can I write this as 8 times root 15? Can I write it as square root 3 times square root 5? It's the same thing, which is square root 15 divided by 2 times root 3. Now, can I cancel root 3 with root 3? Because root 3 divided by root 3 is going to be 1. And then 8 divided by 2 is how much? 2 1 times is 2, 2 4 times is 8. So I am left with what? 4 square root 5. That's my answer. So now do you get it, how we divide two irrational numbers? Let's learn simplification. Simplify the following expressions. 5 plus root 7 multiplied with 2 plus root 5. In your lower grades, you have learned distributive property. You take each term of one bracket, multiply with every single term of the second bracket. Let's look at it how it goes. So 5 times 2, let's write down that step, plus, then we will multiply 5 times root 5, which is 5 root 5. Then we continue. We took the 5 and we multiplied every term in a second bracket. Now we are moving on to the next term. So we will take now root 7 plus root 7 times 2 is 2 root 7 plus root 7 times root 5, root 7 times root 5. For our understanding, we will do one step extra. So 5 times 2 is 10 plus 5 root 5 plus 2 root 7 plus root 7 times root 5 is how much? Root 35. Is there anything that you can add? Are there same irrational numbers? Root 2, we don't have any root 2's over here. Root 7, we don't have any root 7's over here. So we can do nothing. So this is our final answer after simplification. Great. Let's try few more. Let's try this. Simplify. 5 plus root 5 times 5 minus root 5. Now from here, we will make a new discovery. Let us see what is that. Of course, we know how to open the brackets. We will take one term of the first bracket, multiply with every single term of the second bracket. Then we will move on to the second term and multiply every single term of the second bracket again. So let's go ahead. 5 times 5. Let's write it down like this. Then 5 times minus root 5 is minus 5 root 5. So we are done with 5. Now let's go on to the second term, square root 5. And we are going to multiply every single term of the second bracket. So plus square root 5 times 5 is plus 5 root 5. Plus square root 5 times minus square root 5. Plus times minus is minus square root 5 times square root 5. Okay? Now, just one step extra to make the discovery. Let us see. Can I write 5 times 5 as 5 squared? I can. And minus 5 root 5 plus 5 root 5 is what? They both cancel and it is 0. And minus, can I write square root 5 times square root 5 as square root 5 squared? Good. Now here is the discovery. Look at this very carefully now. 5 plus root 5, when it was multiplied with 5 minus root 5, what did we land up with? This 5 was 5 squared. And square root 5 was square root 5 squared. Of course, with a minus sign. Now, can we generalize this term? Can we say when any two numbers are multiplied like a plus b times a minus b, they will land up with a squared minus b squared. This is a general formula that you can remember now. So anything in the form a plus b times a minus b, will be a squared minus b squared. Look at this. 5 plus root 5 times 5 minus root 5 is going to be in the form 5 squared minus root 5 squared. So now we can come back to our problem. 5 squared is 25 minus square root 5 squared is nothing but square root 5 times square root 5, which is square root 25. Square root 5 times square root 5 is square root 25, which is 5. So this is nothing but 5. So 25 minus 5 is 20. So that is the answer. The discovery what we made is here. A plus b times a minus b is a squared minus b squared. We will be using this extensively in our upcoming examples. So remember this. Simplify the following. Square root 11 minus 7 times square root 11 plus square root 7. What do you get? Is this in the form a plus b times a minus b, which is nothing but a squared minus b squared? A minus b, a plus b, whichever comes first, it doesn't matter because it's multiplication. So can I write this as now square root 11 squared minus square root 7 squared? I can. And square root 11 squared is how much? You can remember it's 11, and minus square root 7 squared is 7, and 11 minus 7 is 4. Pretty simple. Now you know how to apply this a plus b times a minus b, which is a squared minus b squared. Let's go ahead. Let's try this. Do you remember the formula which you studied in your lower grades? A plus b the whole squared. What is the formula if you expand? It's going to be a squared plus 2 times ab plus b squared. Remember this? You studied in your grade 8, also in grade 7. So can we apply the same thing over here? Is this in the form a plus b the whole squared? It is. So I can easily apply this formula, which is a squared, meaning root 3 squared, plus 2 times a times b, which is 2 times root 3 times root 7, plus b squared, which is root 7 squared, root 7 squared. Next step, root 3 squared is how much? It's 3 plus 2 times root 3 times root 7 is how much? Square root 21. So this is 2 root 21 plus root 7 squared is how much? 7. Now can I add 3 plus 7, which is 10, plus 2 root 21. That's your answer, because I cannot add these numbers. Let's try this out. Rationalize the denominator 1 over square root 2. What do you observe over here? Look at the denominator. Is it a rational number or an irrational number? It's an irrational number. So the question is telling us to make the denominator a rational number. That's what it means. Rationalize the denominator. So let's go ahead and see how we go about doing that. 1 over square root 2. In order to rationalize the denominator, I will multiply and divide by square root 2. Because why do I do that? because square root 2 and square root 2 divided together is going to be 1. So basically it's not going to change anything. Now let's see. 1 times square root 2 is square root 2 divided by square root 2 times square root 2 is what? Square root 4, which is square root 2 divided by square root 4 is how much? 2. Have I rationalized the denominator now? That's my answer. So you basically, if you want to rationalize the denominator, you need to multiply with the square roots, involving square roots. Let's look at further examples. Okay, let's try this. Rationalize the denominator of 1 over 2 plus root 3. Now 2 plus root 3 is an irrational number. Remember, a rational number added to an irrational number, the result is an irrational number. So 2 plus root 3 is irrational. We are supposed to rationalize. So how do we go about doing that? 1 over 2 plus root 3. We will multiply and divide by 2 minus root 3. 2 minus root 3. This is called the conjugate of this. 2 plus root 3. What is the conjugate? 2 minus root 3. So we multiply and divide by 2 minus root 3. So let's see what do we land up with. 1 times 2 minus root 3 is 2 minus root 3 over. Observe carefully now. Do you remember the formula? A plus B times A minus B is equal to what? A squared minus B squared. Remember that? So now, is this in the form 2 plus root 3 times 2 minus root 3? In the form A plus B, A minus B. So I can easily write it as 2 squared minus root 3 squared. So now my numerator is 2 minus root 3 divided by 2 squared is 4. So I can bring that down. 2 squared is 4 minus root 3 squared is 3. So where do we land up? 2 minus root 3 divided by 4 minus 3 is 1. So have I rationalized the denominator? Yes. So that's great. So this is how we do. Your first starting point, multiply and divide by the conjugate of this. If it's 2 plus root 3, you multiply and divide by 2 minus root 3. If it is 2 minus root 3, you multiply and divide by 2 plus root 3. As simple as that. Let's try one more. Let's rationalize the denominator 1 over 7 plus 3 root 2. So let's write it down. 1 over 7 plus 3 root 2. What's the first step? You multiply and divide by the conjugate of this. And what is the conjugate of 7 plus 3 root 2? It is 7 minus 3 root 2. So I multiply and divide by 7 minus 3 root 2. Fine. So now we have 1 times 7 minus 3 root 2 is obviously 7 minus 3 root 2 over. Now what do you look here? 7 plus 3 root 2, 7 minus 3 root 2. Is this in the form A plus B times A minus B, which is A squared minus B squared? In other words, 7 squared minus 3 root 2 the whole squared, because this term completely is squared. Now let's move on. So my denominator is going to be 7, numerator is going to be 7 minus 3 root 2 divided by, what's 7 squared? 49 minus, now this square has to be given to every single term. So observe carefully, 3 squared is how much? Let's show it here. 3 squared is 9 times root 2 squared is 2. So our next step, the numerator is the same, 7 minus 3 root 2 divided by 49 minus 9 times 2 is 18. And what's the next step? The numerator is still the same, divided by 49 minus 18 is 31, and the denominator has been rationalized. So great going. This completes the lesson. Thank you very much. I hope you understood this. If you have any doubts and you need math coaching and help, you have my number displayed in the first page of the video, as well as listed in the description below. So you can WhatsApp me if you want extra math classes, and share this video with your friends, your teachers, and one and all. Thank you very much. Have a nice journey of learning.